We're given a graph and we need to tell whether x and y are in a proportional relationship. The nice thing about a graph is that it's visual and there is something that we can look for that will right away tell us whether the graph, x and y, are in a proportional relationship. And what we can look for is this. Is it showing a line that passes through the origin? Here's my origin, 0, 0. That's the origin, and I can see clearly that this line is not going through the origin, so therefore x and y are not in a proportional relationship. So that would be my answer. Tell whether x and y are in a proportional relationship. You would say no, x and y are not in a proportional relationship. So what about these values? You can also use these values to prove that x and y are not in a proportional relationship. Let's pick some x and y's. I'm going to pick this one and this one, and this one and this one, to create ratios. And so we'll do y over x, and so 3 over 1 and 4 over 2, and we want to see, are these two ratios equivalent? Are they equal to each other? That would determine whether they're proportional. We already know they're not. And so if I cross multiply, which is one method, you could do 3 times 2 is 6, and 1 times 4 is 4, and you can clearly see those are not equal to each other. So x and y are not in a proportional relationship given the values on this graph. So I can also put a real-life example to this. Let's pretend that, say, the y-axis represents candy bars and the x-axis represents dollars. And so I can say I can buy 3 candy bars for $1. Pretty good. Then if I'm going to pay $2, I should be getting 6 candy bars, but instead, based on this graph, I'm only getting 4. So I pay $1 to get 3 candy bars, and then I pay $2 to get 4 candy bars. And that's how you can tell that that's not going at a proportional rate. So x and y are not in a proportional relationship in this graph. So you'd say no, not in a proportional relationship.